The year was 1985. The Hubble Space Telescope was still 5 years away from launching on a space shuttle. Although nervous, the scientific community was excited. Hubble would revolutionize the way we saw the universe. But Riccardo Giacconi, the then director of the Space Telescope Science Institute, told his team that they should start thinking what would come after Hubble, much further down the road. His team protested, saying that they have more than enough to do with Hubble. But Giacconi was insistent, and so, his team got to work, drawing up concept ideas for what was then known as the Next Generation Space Telescope. Today, the NGST is a superstar, and one of its kind. Today, it is called the James Webb Space Telescope. The need for a new telescope arose in 1995, when astronomers pointed Hubble at a seemingly empty patch of the sky for 10 consecutive days. Many experts predicted the extended observation would be a waste of resources, revealing at best a handful of dim galaxies, but instead the effort was richly rewarded. The resulting image, the Hubble Deep Field, showed the empty spot was actually filled with galaxies by the thousands, stretching back 12 billion years into the 13.8 billion year history of our universe. There were galaxies everywhere. The Hubble Deep Field showed that the early universe was even more crowded and exciting than most anyone had expected, offering observational treasures to the scientific community. Yet, impressive as Hubble's deep field was, astronomers wanted more. And after more than 2 decades of labor, at a cost of some $10 billion, the James Webb Space Telescope finally launched on Christmas Day 2021. By July 2022, the telescope had reached its deep space destination, and its instruments had been put through their paces, and shortly after, its long-awaited first year of science observations began. When Webb released its first set images, it proved that it was worth the wait. It showed us the universe like never before. It showed us that the universe as we know it might be stranger and more complex. The Big Bang Theory as we know it started to tremble. Or did it? Welcome to You Curious? Discover more, know more. First, the basics. According to the inflation theory, in the first second after the Big Bang, our universe was an almost inconceivably hot and dense soup of primordial particles. Over the next 3 minutes, as the cosmos expanded and cooled, the nuclei of helium and other very light elements began to form. Fast forward 400,000 years, and the universe was cold enough for the first atoms to appear. When the universe was about 100 million years old, conditions were finally right for the emergence of the first stars. These giant fireballs were larger and brighter than today's stars, and these first suns coalesced in protogalaxies, which eventually merged to form larger galaxies. This process of becoming, of the early universe's chaos, giving way to the more orderly cosmos we know today, is thought to have taken about 1 billion years. And this is where Webb enters the scene and toys with our cosmology. Alright, story time. Rowan Naidu was sitting at home when he found a galaxy that started the Webb Big Bang debate. As his algorithm dug through early images from the James Webb Space Telescope, Naidu shot to attention. It had spotted an object that on closer inspection was inexplicably massive and dated back to just 300 million years after the Big Bang, older than any galaxy ever seen before. Older than what our understanding of the first galaxies of the universe, which we once thought emerged 1 billion years after the Big Bang. At that moment, Rowan knew that it might be the most distant starlight we had ever seen. The candidate galaxy, named Glass Z13, was beyond astronomers' wildest dreams. But this is where most of us declared that Webb has shattered the Big Bang. Well, not really. Years ago, Hubble gave us the same type of data. Hubble's record for the most distant known galaxy had been GNZ11, spotted in 2015, at a redshift of 11, which corresponds to a cosmic age of about 400 million years. Yes, the latest Webb observations do reveal some strange and unexpected things about the universe, but they don't prove the Big Bang wrong at all. If anything, It makes the Big Bang theory even stronger. In an expanding universe, all faraway points in space move further and further away from each other. As light travels from a distant galaxy, and with the universe continually expanding, the distance the light needs to travel is continually increasing as well. And as space stretches out underneath a beam of light, its wavelength increases, and its energy decreases. So, when light arrives from a distant point in space, it is stretched out, and far weaker. This means that the wavelength of the light is stretched, so the light is seen as shifted towards the red part of the spectrum. The higher the redshift, the further away an object is relative to the observer. Hubble and Webb's observations accurately align with the cosmological inflation, aka Big Bang's model. These old galaxies appear redder than they should, implying an expanding universe. Now, if we could go way back in time, you will see the galaxies coming together, until a point where everything in the universe is confined into one place, just as the Big Bang theory predicts. Not just that, the Big Bang theory accurately predicts how much of each element was made in the early universe. When astronomers look at very old galaxies and stars, the amount of each chemical they see agrees with the Big Bang theory. The so-called tired light hypothesis suggests a non-expanding universe, where light spontaneously loses energy over time. The tired light hypothesis is wrong though, because of the cosmic microwave background. A static, tired light universe wouldn't have any remnant heat from a primordial fireball. Not to mention the fact that distant galaxies would appear blurred, which they don't, and distant supernovae wouldn't be time-dilated by cosmic expansion, which they are. The only model that supports all the evidence is the Big Bang. In conclusion, debunking the Big Bang theory will take a lot more than finding early galaxies. Yes, Webb observations have found very redshifted, very young galaxies that are both common and surprisingly mature. It's the kind of puzzling and unexpected data astronomers were hoping for. It's why we wanted to build the Webb telescope in the first place. And it tells us that while the Big Bang model isn't wrong, however, some of our assumptions about it might be. Neil deGrasse Tyson explains it very nicely in a video hosted by Chuck Nice. He explains how the Big Bang theory has been developed over the past century, with many observational evidences that one cannot simply throw out the window. The link to the video is in the description below. Do watch it. Until then, tell us what you think, and don't forget to subscribe to You Curious. Discover more, know more.